Hi, I'm Dr. Valerie Camille Jones, and a lot of people have been asking me to explain the lesson that I did with my students with holograms and dilations and scale factors and similar figures with the Black Panther movie, as well as the Black Panther comic book. So I wanted to explain that kind of briefly, and hopefully you'll be able to use that in your classes, educators. All right, so first of all, this all started for us a couple weeks ago when we decided that we were going to integrate Black Panther into our lessons. And when I mean we, I mean the teachers at Ron Clark Academy where I work. So I was trying to find a way to take some of the concepts that were in the movie and make them mathematical. So I knew that there was going to be a lot of technology. I actually kind of followed the comic book myself. I love Comic-Con. Anyway, so I wanted to find a way to kind of bring that math into my class and get the kids excited. So I thought about using scale factor and holograms. So the first thing I did was I sent my students a video, actually 2 videos. One video was on YouTube, and it's called Scale Ella. It's really fantastic. It also has a comic book that goes with it. It's through a company called Math Snacks, and they have a website called mathsnacks.org. I use all their videos. I love them so much. And in this video, there's a superhero. She's a gorgeous woman that looks kind of like me, and she kind of saves the town from a villain called Scaleo, who scales things down and blows things up to make them not convenient for the people of the city. So Scale Ella comes in and she uses mathematics to fix the situation. So I had the students watch that video to get a nice review and to understand how scale factor works. And I also had them watch a video on how to make holograms, how holograms are actually made. And we talked about that online, and we talked about it in class, as far as how holograms can relate to scale factor. And what I want to say, though, is if you're ever going to give students videos to watch at home for homework, always use another program that I love so much called Edpuzzle. Because Edpuzzle allows you to input questions into the video, so when students are watching the videos, up pops a question, and that's a way you can make sure they understand what they're watching, and a way for you to monitor that they're watching the entire video. But anyway, we had a great discussion in class, and the students recognized that depending on the beam of light and where it's located, it could help the hologram image get bigger or smaller, and that's how it kind of relates to scale factor. So I gave the students a homework assignment. It was like this, but on a worksheet form, where I took a character from the Black Panther movie. I made 5 reference points, and I wanted the students to translate them on the coordinate plane and also to dilate it by 3. And we talked about how when you use a dilation, if you're multiplying by like an integer, it might get bigger, but if you're multiplying by like a fraction that's in lowest terms, that's not an improper fraction, but it's a normal fraction, that is going to actually make the scale smaller. So we had a discussion about that and what they thought the connection with holograms and scale factor really was, and it led them to them making their own project. So you're seeing some images now of the project the students created that kind of took the homework assignment that I gave them and amped it up a level. And these projects, where they got to design their own scale factor, determining if it was going to be smaller or larger, and depending on how they interpreted the homework assignment I gave them. And then I wanted to give them a surprise. So I wanted the students to experience holograms or a hologram-like image in real life, in the classroom. I did some research, and I found some examples on YouTube, and I was like, oh, this is pretty cool. But I wanted the students to have to earn the right to make their hologram-like image. So the videos I found on YouTube, they are Googleable. You can find them now. You can just Google hologram video, and all these images will pop up. You'll see 4 images, and then you'll see like an X in the middle. That X in the middle is where you need to put your hologram projector device. So this is the hologram projector device that could fit in the center, sitting up, and the 4 images are flat on the iPad, but this device helps it reflect to make it look like it's floating like a hologram. Now, this is not a true, absolutely definite hologram, but it presents a hologram-like image for the students, which is good enough for them to see the ability of it. I did not mind that my students were seeing this hologram-like image in this fashion because we did the research prior to on how real holograms are made and how real holograms are created. And we had all those class discussions about it. So, the math. I needed the students to apply their mathematical skills with the project that they did, with the lesson we had, to making this. It's made from 4 trapezoids. And these trapezoids are isosceles trapezoids. So my students had to actually find the dimensions to cut these out. I used plexiglass, but I know that some people have used CD cases and other people have used transparency, but I find that plexiglass is the best. So you can get plexiglass at any craft store, and sometimes it comes in big sheets like this that you have to cut out, and then it has like film you tear on both sides, so that way it's perfectly clear. This right here was made from a CD case, and you can't really see it, but it's kind of splintered, and I find that if you just use regular plexiglass, you're able to cut it with scissors, and you have no problems. Now the dimensions. If you take regular graph paper, and you use 2 boxes by 8 boxes, and then a height of 5, that, I guess, size would fit an iPhone if you were to use an iPhone to project the image. So I told the students, I said, okay, if that fits a trapezoid for an iPhone, I'm going to give you the scale factor to actually make the trapezoids that will fit an iPad. And if you're able to figure that out, then you'll be able to cut out and make your projector machine, I call it a projector, but you know, able to mirror, and it'll allow you to have your hologram come to life. So the scale factor that will scale this up is really 1.5 or 3 over 2. So according to those dimensions, it'll be 3 across, 12 on the bottom, and about 7.5 in height. So once the students discovered that, I had them go ahead and cut it out and tape these ends together. You tape all the ends together and make this. And then you can put it on top of those videos in the X, and the hologram will appear. Now what I want you to know is that I used a lot of math for this. So in my class, I wanted the students to be able to use coordinate geometry. So I gave them these points, and then I told them to find the measurements of all the sides. So these, they're just counting the boxes. But these diagonals, they would have to use the distance formula according to the coordinates, or they could use the Pythagorean theorem to find the length to those diagonals. And then when they multiply each side by the scale factor, they'll get this image. I had them put it in quadrant 4, but you could have them put it wherever you want, as long as the dimensions are adequate. So that's it. That's how I did my lesson. If you have any other questions, let me know. I will attach the PDF to this video, so that way you'll be able to download it, and hopefully that works. Thank you so much. Bye.
That's pretty cool, right?
Yeah. Oh, look at Cindy's. Look at Cindy's.
I like these people. I'm going back.
That was cool.
Look at my minions. They're upside down.
That was
my minions.
pretty cool, right?
Yay! It's pretty weird. She's just like staring at me. But it's cool because it's like 3D.
So that's Michael Jackson.